Okay, so I'm going to walk through how to make the three graphs necessary for this problem. The first thing I'm going to do is copy and paste column A here. I'm just going to make the independent variable each time that I need it, so that when I make graphs I can just highlight the independent and dependent variables next to each other. Okay, and then this column is going to be for the concentration. So I need to say a formula that says equals the first number, the absorbance value, divided by the molar absorptivity value. So it's this number divided by this number. But I need to put dollar signs in because otherwise this column is going to move down to this column and I don't want it to do that. So now that I've got my correct formula, I can copy and paste that down. Okay. All right, and then the next column that I wanted was the log of the concentration. So I'm going to say ln of x here. So that's equals the log of the concentration, which is this column here. And then copy that down. Okay, and then the last column that I need is the inverse of the concentration, which is going to be 1 divided by the concentration number. And then copy that down. Okay, and the next thing that I need are my three graphs. So I need a graph of time versus concentration. I'm going to say insert a scatter chart. I need a graph of time versus the log of the concentration. That's the second one. And then the third one I need is the graph of the time versus the inverse of the concentration. Inverse a scatter chart. Insert a scatter chart. Okay, and then I need to evaluate which one of these looks like the most straight line. This one is too curvy. This one is pretty straight. This one's pretty curvy. So this is the one that I'm going to want to evaluate the equation of the line for. So I'm going to say add trend line. And I want it to be linear and to have an equation in R squared value. But I'm not going to trust this value of the slope for my k constant. I'm going to go ahead down here and say the reaction order is 1. The k constants, I'm going to recalculate the slope. So it's the slope of these y values. Okay, so the change in y divided by, you can see it's telling me, I want the known y values and I want the known x values, and then the x values are the column over F202. So this is saying E2 to E, oh, I almost did F, E202. Okay, so I've got my rate constants and my reaction order. And then the rest of these things are pretty straightforward. So the equation for T90 is that you take the logarithm of 0.9 and divide it by the k constants. So you say equals to that formula, and then that's your T90. And then I need the remainder of these things. I need T1. For number 4, I need the first temperature, the second temperature, the activation energy, and the R constant. So I'm just going to put what those are here. Convert this into joules now because the R value is in joules, and then I'm going to call this 273 and this 300. These two numbers could be more precise, but that's okay. So now K2 is going to be equal to, by the Arrhenius equation, K1 times the exponential of negative this thing divided by this thing times 1 over this thing minus 1 over this thing. Okay, so I needed to put a parenthesis after that. I don't know what happened in my formula. This should have been equals this constant times all that stuff. Okay, and I need a negative sign up here. I think I needed a negative sign. Equals negative slope. And then this also needed a negative. Okay, so that's my K2, and then my final T90 is going to be the same formula. Divided by my new K2. So you get 23 days. These two numbers for the temperature should be, could be a little bit more precise, but that's how to do it.